Hi there, folks. Today we're looking at a review of factoring. So we're going to go over all the different methods by which we've factored things. This is going to be really important moving forward. So first of all, factoring itself is basically the reverse of the distributive property. Remember, the distributive property is when we multiply in. Factoring is when we divide things back out. All right. So when you think about the distributive property from the perspective of distributing a single term, all right, factoring is dividing that single term back out. When you think of it from the process of multiplying two binomials by distributing or foiling or something like that, factoring is going to be that factoring by grouping method that we're going to do to factor things back out. Okay. So again, all of these things are just the reverse of the distributive property, but we have different methods for factoring, for undoing the distributive property, because we have different types of distribution that we've looked at. Okay, so distributing is multiplying in, factoring is dividing out. The first one we're going to look at is factoring out the greatest common factor. Remember, the greatest common factor is the thing that divides evenly into each thing. All right. So when you take a look at this first one, I always start with the numbers and say, okay, between the 2 and the 6, they're each divisible by 2. So the greatest common factor has a 2 in it. And then when you look at the x to the 5th and the x to the 1st, the greatest common factor is an x to the 1st. They're each divisible by an x to the 1st. Because remember, when we divide, we're actually subtracting the exponents. So think of it this way: when you see variables, think about how many x's I can take away. The first one has 5. The second one only has 1. I can only take 1 x away from each. So it's a 2x that I factor out and I divide. 2x to the 5th divided by 2x is an x to the 4th. See, the 2's give me a 1, and I subtract the exponents. 6x divided by 2x is a 3. Again, 6 divided by 2 is a 3. X divided by x is a 1. Kind of cancels out. And that's it. The next one, greatest common factor, I look at the 12, the 3, and the 9. The biggest number that divides into all of those is a 3. And now again, when I look at the variables, I know that division is actually subtracting the exponents. So think about how many x's you can take away from each of those. The most you could take away is 2, so it's an x to the 2nd. And again, as I divide, I subtract the exponents. So here, 12 divided by 3 is a 4, subtract the exponents. 3 divided by 3 is a 1, subtract the exponents. 9 divided by 3 is a 3, subtract the exponents gives me a 0, so that's an x to the 0, which is 1, so it's gone. Okay, again, we're taking the x's away. We're subtracting the exponents because that's our rules for exponents. This one, between the 4 and the 24, they each have a 4 in common. I can divide a 4 out. Between x to the 3rd and x to the 12th, the most I could take away in terms of x's is x to the 3rd. Between y and y to the 8th, I could take out a y. And now I divide, and here's the thing: 4x to the 3rd y divided by 4x to the 3rd y gives me a 1. Remember, if everything goes away, but we're talking about division, when everything goes away, you're left with a 1. And then here, this gives me a 6. Again, when I divide, I subtract the exponents. That's a 9 and a 5. Okay? But again, greatest common factor. What's the biggest thing that we can divide out? Divide it out. That's the process of factoring. Okay? And then we upgrade to factoring by grouping, which is essentially just doing the greatest common factor twice. All right? So factoring by groupings, where we put the terms in groups of 2 using parentheses. So I put them all in groups of 2. Then I factor out the greatest common factor from each group. I essentially do what I did in the previous 3 examples, but I do it twice. I do it with each of the groups that I've created. And then I factor out any common polynomials. I look for big chunks that are the same, and I take them out. For example, if I look at this guy, again, factor by grouping, I put them in groups. So I'm going to put these 2 together, and I'm going to put these 2 together. And remember to include the sign here when you do that. All right, that's an important part of this thing. Sorry, I erased too much. But now we just factor out of each of these groups. So I ignore the second group. Look at the 3n cubed minus 12n squared. The greatest common factor is a 3n squared. And now I divide out the 3n squared, which leaves me with an n minus 4. Okay? Out of the second group, I got to look for the greatest common factor. I can factor a 2 out, so I'm going to put a plus 2. And it's important to include the sign. Tell me whether you're factoring a positive 2 or a negative 2. So I factored that out. That leaves me with an n minus 4. And now I look for big chunks that are the same, and I should see that I've got this chunk of n minus 4 that they have in common. So basically, I'm going to take out the n minus 4, and if I were to take the n minus 4 and write it here, think about what would happen if I took the n minus 4 out of this first chunk of stuff. I'd be left with a 3n squared. And if I took the n minus 4 out of this second chunk of stuff, I'd be left with a plus 2. And so that's what happens. I just imagine what would happen if I took away the n minus 4s. I'd be left with a 3n squared plus 2. Those are my two factors, and I have to have parentheses around them because I'm undoing the distributive property from two binomials, okay? This one, same kind of thing. I'm going to put them in groups. Out of the first group, I can factor out a 3x cubed, which leaves me with an x plus 3. Out of the second group, I can factor out an x. So I'm going to do a minus x, which leaves me with an x plus 3. And be careful with your signs there. And now I see that I have a big chunk of x plus 3 in common. If I take that away, I'm left with a 3x cubed minus x. And the thing about that is, it doesn't matter what order you write these in. If you want to write the 3x cubed minus x first, that's fine. The other thing is, as I look at these two factors, you see that one of these still has a greatest common factor. This first one still has an x in it, so I have to take that x out. So now I'm going to take the x out, which leaves me with a 3x squared minus 1, and then an x plus 3. And the thing about that is, if you look at the original problem, they all have an x in common. You can always factor out the greatest common factor first, and you should if you recognize it. But you always have that second chance to factor it out at the end, okay? The other thing about factoring by grouping is you have to factor something out even if it's just a 1, all right? So even if it looks like they don't have anything in common, factor a 1 out, okay? Let's talk about factoring trinomials. Remember, factoring trinomials, we're working our way to factoring by grouping. So we build a bridge. We multiply the first coefficient by the last coefficient. Then we come up with two numbers that multiply together to give me the bridge, but add to the middle coefficient. So again, build a bridge, and now I need two numbers that multiply to the bridge, but add to the middle number. All right, and that gets all three terms involved. Now I rewrite the middle term using those two values I just came up with, and then I factor by grouping. All right. And again, this is all review, so we're just kind of breezing through this. But here it is in practice. Remember, I build a bridge, so I do the 2 times the negative 6. And I have to include those signs as I build the bridge, so that's a negative 12. All right? So now I need two numbers that multiply to a negative 12, but add to the middle number, which is right here, it's a 1. Okay? And notice it's a positive 1, so I need two numbers that multiply to a negative 12, but add to a positive 1. So that's a positive 4 and a negative 3. All right? So now I rewrite the middle term. I do 2x squared plus 4x minus 3x. I rewrite that plus 1x as a 4x minus 3x because it's the same thing. I use those two values I came up with to rewrite middle term. Now I have 4 terms, so now I can do factor by grouping. Out of the first group, I can factor out a 2x. That leaves me with an x plus 2. Out of the second group, I can factor out a negative 3. That leaves me with an x plus 2. They have the x plus 2 in common, so that means my two factors are going to be the 2x minus 3 and the x plus 2. Okay? But again, we're essentially just getting this to a point where we can do factor by grouping. That's the goal when we factor trinomials. This guy, same kind of thing, build a bridge. Two numbers that multiply to a 20, because again, I just did a 4 times a 5 there. So multiply to a positive 20, but add to a positive 12 is going to be a positive 10 and a positive 2. And now I split up the middle term and I factor by grouping. So now that 12x becomes a 10x and a plus 2x. And now I group them. Out of the first group, it looks like I can factor out a 2x, which leaves me with a 2x. Oh, sorry, that does not look good. Plus 5. Out of the second group, it looks like I can't factor anything out, but remember, factor by grouping, you have to factor something out. So here, the only thing I can factor out is a 1, so that's what I do. And now I've got the 2x plus 5 and the 2x plus 1. And again, it doesn't matter what order you write these in. This time I'll write the 2x plus 5 first, because I can. But again, that's personal preference in terms of which order you write these in, okay? Split up the middle term factor by grouping. These guys, same kind of thing. So here I build a bridge, and notice there's a 1 out front here, so that gives me a negative 12. Now two numbers that multiply to a negative 12, but add to a positive 4 are a positive 6 and a negative 2. And remember that on these, when you have a 1 out front, you're allowed to do a shortcut here. So you could split up the middle term factor by grouping like we just did. But when there's a 1 out front, remember you're allowed to go right to the answer and say, okay, it's going to be an x. And since this was a plus 6, it's going to be a plus 6. And then it's going to be an x. And since this was a minus 2, this is going to be a minus 2. And those are my two factors. And I am done if I could write a parenthesis. Okay? Remember, you can use that shortcut on these, but only when there's a 1 out front. All right? So this one, same kind of thing. I build a bridge. Two numbers that multiply to a positive 20 but add to a negative 9 are a negative 4 and a negative 5. Because there's a 1 out front again, I get to use the shortcut. So I go right to the two factors. It's an x minus 4 and then an x minus 5. Okay, so remember, right to the two factors, but only when there's a 1 in front of that trinomial. Okay? And then the last thing we had in terms of factoring was difference of squares. Remember, subtraction of two perfect squares always factors into conjugates. And if you recall, conjugates are when we basically have the same binomial twice, but they have different signs. So like an x plus 5 and an x minus 5. All right? An x plus 8 and an x minus 8. Those are conjugates. All right? But that will only happen if I have perfect squares being subtracted. For example, if I look at this guy, here, x squared is a perfect square. It's kind of in the name, x squared, right? 49 is a perfect square, and there's subtraction, which means this is going to factor into conjugates. One will be a plus and one will be a minus. And then essentially filling this in is like taking the square root. The square root of x squared is an x. The square root of 49 is a 7. And those are my factors, okay? You could put a 0 in for the middle term and go up like we did previously and build a bridge. Two numbers that multiply to this but add to this, okay? You just have to put a 0x in the middle. And that will work every time, okay? This one, perfect square minus a perfect square. So this is a difference of squares, so it's going to factor into conjugates. One's a plus, one's a minus. Square root of x squared is an x. Square root of 100 is a 10. And that's it. We just have to be able to recognize difference of squares. This one, also difference of squares. Look at this. 4 is a perfect square. X squared is a perfect square. 121 is a perfect square. It's subtraction, so that is a difference of squares. Okay? The square root of 4 is a 2. The square root of x squared is an x. One's a plus, one's a minus here. The square root of 121 is an 11. That's how we factor difference of squares. It's really easy to factor difference of squares. The most difficult part about that is recognizing difference of squares, seeing the perfect squares and seeing that it's subtraction. Okay? Hope this was helpful. And again, we're going to use this a lot moving forward. So make sure you're okay being able to do all these different factoring types. All right?